Welcome back from an ad break. So now we're just going to jump back into our lesson. So our first concept, we said that you're going to be looking at the reactions of iron with oxygen. And remember that our main idea is we are looking at the reactions between metals and oxygen. So we're going to start with our metal being iron. So let's start. We know that reactions of metals with oxygen, so reactions in general, they are that we know that any chemical reaction can be represented by using models. We know that the models of the atoms, words, or chemical symbols. Remember the chemical symbols from the periodic table. We also know that all chemical equations have to balance. We know that what we have on the left-hand side must be equal to what we have on the right-hand side. So which means that there should be the same number of atoms for the reactants and also the products. Remember, reactants, left-hand side, products, right-hand side. And then, reactions that involve the burning of substances are known as combustion reactions. Remember, when we're burning the metals in the presence of oxygen, that reaction is known as a combustion reaction. So during this reaction, metals react with oxygen to form metal oxide. Remember that we find our oxygen as in a mixture of with air. So our air consists of oxygen and nitrogen and other substances. So now when our metal is reacting with air, particularly oxygen from it, we're saying that it is undergoing the process of combustion. So now, what is it that, how do we then know that a metal has reacted with oxygen to form something? Now we are going to be using, or we use steel wool to demonstrate the reaction between iron and oxygen. So our iron in this particular case is going to be our steel wool. Now remember that steel wool is a wire wool which is made of fine steel threads. We also need to know, we need to remember that our steel wool, it is a wire wool that is made of fine steel threads. Then steel, it is an alloy, which means that it is made up of different metals, and the most one that is consistent in that particular mixture, it is going to be that of iron. So when steel wool burns in air, and remember that our air, it is a mixture of different gases that are including oxygen. You must remember that the air that we breathe, it is a mixture of gases that includes oxygen. Remember we initially said that oxygen makes up 21% of our atmosphere. So the air that we breathe in consists of that 21% of oxygen. So in this particular reaction of iron and oxygen, what happens is the wool or the steel wool, it is going to burn in the presence of that oxygen. So when now it reacts, when it actually burns in that presence of oxygen, what happens? So when iron reacts with oxygen in the air, it rusts. And then when it does that, it forms something called the iron oxide. So we're basically saying that when iron reacts with oxygen, it's going to form iron oxide, which then means our iron and our oxygen, those are going to be our reactants because they are written on the left-hand side of the chemical equation. And because there's two of them, they are going to be separated by the plus sign. Then the product which is going to be formed from there is going to be iron oxide. Now to represent that particular reaction using models, we have that the red circle is going to represent the iron, and then the two yellow circles are going to represent the O2. Remember that O2, it is oxygen, and it is written as O2 because it is a diatomic molecule found in group 7 of the periodic table. So the product that is going to be formed here is going to be our iron oxide. So the model that represents iron oxide is going to be this. Remember that the red circles, the two red circles are representing iron, and we find iron in the transition elements of our periodic table. So it's not in group 1, also not in group 2. It is found in the transition metals. Now, in terms of a chemical symbol of this particular reaction, we have that Fe, being our iron, reacts with O2, our diatomic molecule, to form Fe2O3. Now, we also need to note that this equation is not balanced, and we just said that now that all reactions must balance. So we need to be able to balance this equation. So how do we balance it? We are seeing that on the left-hand side, we have one iron, one Fe, and then on the right-hand side, the products, we have two of them. So there's one here, and then there's two there. Now, with regards to the oxygen, the left-hand side, the reactants, we have 2 oxygens because of that subscript 2. And then on the right-hand side, we have 3 oxygens because of that subscript 3. So we need to balance. We're seeing that both the oxygen and the iron are not balanced. We need to balance them. So how do we then balance? So we rewrite the equation. And then from there, we're seeing that we have 2 ions there on the right-hand side, and we have 1 on the left-hand side. If I substitute that with, if I put in a 2 there, I now have 2 ions on the left-hand side, and then still 2 ions on the right-hand side. So the iron is balanced now. But the problem is the oxygen is not balanced. There's 2 on the reactants and 3 on the products. So how do I then balance? If now I were to put in a 2 here, now I will have 2 multiplied by 3, I will have 6 oxygens on the products. But on the reactants, I still have 2 oxygens. So if I then put in a 3 there, so that 3 multiplied by 2 is going to be 6. So 6 oxygen on both sides. So they are balanced. Now you notice by balancing the oxygen, I've created a problem because now the iron is now imbalanced. I now have 4 ions on the right-hand side being the products because 2 multiplied by 2 gives me 4 for the iron. But I still have 2 ions on the left-hand side. So that's an easy fix. You just simply erase that and you put a 4. So now everything is balanced because you see 4 iron, 2 times 2, 4 iron. 3 times 2, 6 oxygen, and then 2 times 3, 6 oxygen. So all the atoms of this particular equation, they are balanced. So learners, to summarize, we need to remember that when iron reacts with oxygen, it forms iron oxide. So before we go to our next concept, let's quickly go for an ad break, and I'll see you just after this.